So for the first question, the length of the line is given as 15 mm, f is given as 10 gigahertz. So we'll find lambda, and that will be 30 mm, and therefore it is a lambda by 2 line, right? For the next, what we'll do now, we will find, let's draw the line. So we'll see. So this length is lambda by 2, right? The first question says to find the input impedance at 7.5 mm from the load. So 7.5 is equivalent to lambda by 4. So I'll put the Smith chart. Now Z0 is given as 50 ohm and ZL is given as 75. Just see, ZL is given as 75 minus J100 ohm. So the next step is to find out ZL bar, and that will be equal to 1.5 minus 2J. Now we need to locate this point on the Smith chart. So we'll now see the Smith chart. So now we have the Smith chart. So we need to locate 1.5 minus 2J. So first of all, we need to find the 1.5 circle. So this is 1.4, 1.6. So this is in between a 1.5. Now we go below the horizontal line because there is a negative sign, that is minus 2J. So now we need to find the 2J line. So this is the 2J line. So we'll need to find the intersection of 2J line with this point. So this is 1.5 and this is 2. So it will be here, right? So I have marked the intersection of 1.5 to 2J, right? Now we need to draw a line passing through the center of the Smith chart and this intersection point. So now we draw the line. So now I have drawn the line. The next step is to draw a circle, and the radius of the circle will be the distance from the center to this point, right? So I'll draw the circle. So now we have drawn the circle, right? As you can see, we have drawn the circle. So the question is, so as we have drawn the circle, we also going to find out the reflection coefficient angle. So it is around 38 degree. So this is 38 degree over here. So okay, this is 38 degree, and next is to find the reflection coefficient. So I have drawn a straight line from this intersection point downwards. So if you go downwards, you can see it is something around 0.58. Okay, so we can mention it 0.58. Okay, and here is the angle is around 38 degrees. Okay, so we will mention this part that we have find out the reflection coefficient as well as its angle, right? So now we'll go this over here and find the reflection coefficient, that is 0.58 with an angle 38 degree, right? The next question is asked, when we move lambda by 4 uh, towards the generator, so what will be the input impedance? So now we will solve it. So the theta change will be equal to 740 into 1 by 4, that will be 180 degrees. So we'll go 180 degrees clockwise. So if we'll go, we'll reach over here. Now we need to focus on this point to find out so this coordinates. So it will be, just focus this point. So it will be, j values will be 0.32, j value will 0.32, and the r value will be, I'll follow this circle, so 0.24. So I'll write z in, okay, z in is equal to 0.24 plus j 0.32. Why I'm writing a plus? Because it is above the horizontal line, and we can, this will be z in bar, so z in will be 0.24 plus j 0.32 multiply by 50. So it will be giving you how much? 12 plus j 16. Okay, the next question says that what is the input impedance after the 15 mm from the load. So for the 15 mm, theta change will be 720 into 1 by 2, that because 50 mm is equivalent to lambda by 2, so it will be 360 degrees. That means we need to start from here and then we move to whole 360 degrees, and it will be again will be at this point. So the at after the lambda by 2, the line impedance will be same. So I'll write it, this is z in 1, I'll write it z in 2, so that will be equal to zl bar, and therefore z in 2 will be equal to zl, and that will be equal to 75 minus j100. It is a very easy question, right? One can find the same answer, nearly the same answer, by using the formula, right? So by using the formula you can also find the answer. So for that, what I'll do, so I have used the formula for reflection coefficient and z in. I'm only talking about the lambda by 4 line. So if you see, reflection coefficient is given zl minus z0 upon zl plus z0, and it is a 0.57 plus sorry, angle 37.27, and z in is equal to z naught square upon zl, because the lambda by 4 line, so it is 12 plus j16. So if you compare both the result you have got the Smith chart and the result you have got from the formula, it is nearly same. right? Now we talk about the question number second. So again, the question number second is very much easy. I think you only need to draw the Smith chart, that's all. So in question number 3, sorry, second, it is given as Z in is equal to 100 plus J 150, right? And they have given Z naught is equal to 50 ohm, length is equal to lambda by 3, and they wanted to have what is the value of ZL, right? So up till now we have solved the questions such that ZL was given and we need to find Zin, but in this question Zin is given and we need to find ZL, right? So in this case, what we do first, we need to find Zin bar, that will be equal to Zin divided by 50, so 2 plus 3J, right? Now what we do, we try to locate 2 plus 3J in the Smith chart. Okay, now I have marked 2 plus 3J over here. You just see this is 2 line, this is 3J line, so I have marked it over here. Now I need to draw a straight line passing through the center of the Smith chart and this particular point. So I'll draw it and then I'll draw a circle as well. Okay, so what I have done, I have drawn the line as well as I have drawn the circle, right? So let us find the angle for the reflection coefficient, and the angle is given as 27 degree, right? So it not will the reflection coefficient, but it will be let's find the only I'm finding the angle, so it is 27 degree, right? Now as we know the line is lambda by 3, so we need to move 240 degrees in the anti-clockwise direction, because in earlier case uh, z uh, Zdual was given and we have asked to find out the Zin, but in this case Zin is given and we asked to find the Zl. Therefore we move in anti-clockwise direction 240 degrees. So from here I'll start moving in anti-clockwise direction, here only 180 degrees, and then this will be your 240 degrees. So I find the angle 260 degrees. So what I do now, we need to focus on this particular point. So we need to find out the coordinates of this particular point. So it is very easy, the J component is 0.92. For the R component we need to follow this line, and will follow the same, it will be 0.26. So ZL bar will be 0.26 minus J 0.92. So ZL will be given as 50 into 0.26. So that will become around 13 minus J 46 ohm. So this is your answer, 13 minus J 46 ohm. You can again verify the same with the formula, you might have, you might get a slight difference in that, but that is acceptable. Okay, thank you.